I collect some real turds, don't I? Just for comparison, this is Taz's example of this model. Beautiful, isn't it? Perfect cosmetic condition, or as near perfect as a 50-year-old TV can be. Here's mine, which is in anything but perfect condition. I collect some real crap, don't I? Some real crap. This is a out of focus picture. Come on, focus. This is a Pye CT200 from about 1974. What's going on with this going out of focus? Come on. It's colour television, 625 lines obviously, solid state. This was in the middle of when different manufacturers, at least British manufacturers, were moving over from valved designs to solid state, or at least from valve and transistor designs, solid hybrid, whatever, hybrid designs to fully solid state. There was still a few left. I think that Thorn, right, their colour televisions were all solid state. They started off with they started out making colour televisions by making them all solid state. They're black and white televisions at this point. The 1500 chassis was still hybrid. And ITT, I think theirs was. I think their colour televisions were hybrid. Rediffusions were. And I'm trying to think of a few others. Decca, right? Their Bradford chassis was still being made at this point, and there's probably a few others that I can't really remember right now. Even a few European ones that were being imported at this time, like the Courting Transmare, were hybrid. But yeah, this model was not Pye's finest hour. Pye made some very good television sets, very good, well, not just televisions, but very good electronics. But like any other manufacturer, they also made very bad stuff as well. This model, CT200, was designed to compete with the likes of the Thorn 8000 series, which was a 17-inch colour set, introduced in 72 or 71 or something, and the 17-inch version of the Decca Bradford, which Taz has an example of as well. And to try and I guess reflect the reduction in price or reduction in screen size. I can't remember whether the screen size was the deciding factor in reducing the price, or the price the deciding factor in reducing the screen size. But anyway, they decided to start trying to really bring down the cost of colour television sets, which were a significant expense at the time, 50 years ago. they were a significant expense to buy, right, or to rent, right. And if you bought them, they were also a significant expense to maintain. And also, whether you bought or rented, the colour license was also quite. You were shelling out quite a bit of money also for the colour license as well. So that was basically in the first few years of television, of colour televisions here in the UK in the early 70s, very late 60s. So manufacturers started to come out with cheaper models, right, to try and further the uptake of colour TV. Decca just took their Bradford chassis, made a few circuit modifications to the components in it, and then squeezed it into a cabinet for a 17-inch tube. And I think, in fact, well, I don't even think, but I know they also made a couple of different models with an 18-inch tube as well. I've got an example of one upstairs. And then Thorn took the approach of completely designing a different chassis for their 17-inch televisions, for their cheaper range of models, 17-inch up to 25 or 26-inch. They had the 8000, 8500, 8800, and then this is in chronological order, and then the 8000A at the end, back in the late 70s, 1977 or so. They released the 8000 in 71. They were a series of chassis that were completely designed for use in lower priced colour television sets, and they were fairly good. Right? They have the critics and they have the fans, but they were completely different range of chassis models from the more expensive televisions, which used the 3000 and 3500. And then Pye did this, and the idea was quite a sound one. The idea was to do, like Thorn had done, to design, to not take an already existing design and then just cut down on the cost by removing some components or whatever, but it was to, their idea was to design a circuit from scratch that was deliberately designed to be used in televisions that were just for the lower end of the price range. And somewhere along the line this went wrong, and what I think happened in comparison to what Thorn did, Thorn, even though they were cutting costs and therefore for want of a better term, they were cutting corners, Thorn still put their televisions through design and development stage. It seems as though the accountants and the design engineers worked in. It seems as though the designers and the accountants worked with each other very closely to produce a television that was as reliable as their as their other models, the 3000 series and so on, but was made down to a price. So, and I get the impression from the reputation that these televisions have, these Pye CT200s, is that the engineers and the accountants at Pye didn't work together very closely. And I get the impression that after this when this had been going through design, they used all sorts of cheap options to reduce the component count. I mean, for example, I think I seem to remember reading that the overvolt protection in these is just a fluorescent lamp starter switch, glow starter switch. Don't know if you'd find one in there, probably. And the real pièce de résistance with component, cutting back on components, the component count, is that these had absolutely no EHT regulation at all. That means, in English, that EHT regulation is where, well, what can happen is if the power that's applied to the tube from the line output transformer, if that varies, then the picture will balloon in size or shrink. It actually goes the opposite way to what you might initially think, where you might initially think that if the voltage decreases, the picture goes down. Actually, no, the opposite. It's the opposite. If the voltage, you might think if the voltage decreases, the picture goes down, and if it increases, the picture balloons. Actually, the opposite is true. If the voltage goes down, the picture balloons. If the voltage goes up, the picture decreases. I say picture, I mean raster. But and for it to maintain a constant picture size, a constant raster size, and not to be influenced by brightness on the screen, because more brightness equals more, well, in theory, I think, means more EHT. The picture needs, the EHT needs some kind of regulation. So there is, in 99.9999999% of CRT televisions, there is a circuit to do that, to stop it from varying in size when the picture on the screen varies. It works, I guess, in a roundabout sort of way by smoothing out the EHT, I think. And these did not have that. However it made the picture stable on EHT, these did not have that. So what you get, and one that's often quoted on the on UK vintage TV collector groups on Facebook and on the forums like VRAT and UK VRRR and Goalborn, I think, as well. Whenever these come up, this model is an anecdote of when you were watching Top of the Pops, which was, of course, a chart music show with the pop stars of the day singing their songs, or really miming their songs in the studio. You'd obviously get flashing lights and all that sort of stuff. And early 70s, this being glam rock, lots of reflective surfaces on stars' outfits and that sort of things. So lots of sources of flashing on the picture. So that would mean that the picture on these would sort of balloon slightly and just go odd shapes, like trapezoid shape and that sort of thing. So it's not one of Pye's best. And the other, almost forgot the other way that they cut costs, as far as I can work out, really sealed the reputation of these televisions among television engineers and the like, where they, to cut costs, they completely, they're either partially or completely, I would like to think partially, skipped the R&D department, the R&D stage, or whatever. They completely skipped the step where some were put on test and stock faults were ironed out before releasing it to the public. So, as far as I can work out, these were released to the public pretty much in raw form, in the sense that faults manufacturing defects hadn't been fixed and ironed out before the model was even announced and released. So these sets, even when they were just barely out of their wrapping, days, weeks, maybe even in a few cases just hours old, they started to break down. And that is the reason why television engineers probably think of these as among the worst. Probably not one of the worst to service for them to actually fix it. I believe that they are fairly conventional circuits or conservative circuits, but just for the number of faults, stock faults that these had that should have been ironed out at the factory before they were even released, before they were even first put on sale, that's what sealed their reputation. And also the fact that they used this model, I think, which is the basic version of the CT200, uses a low focus voltage unipotential CRT, which, from what I've read, didn't last very well. It lasted quite poorly. And then, to top it off on this particular example, of course, as you can see, it's had a lick of flame in the past. Fortunately, if I bring it forward, there's no fire damage in there. So this TV did not catch fire as such, and did not start a fire. Something nearby at some point in its past had started a fire or caught fire, and then the speaker grill and part of the front glass has suffered. Also, I don't know if, because I don't know, we'll find out when I test it, I don't know if the whatever's caused the heat damage around here might have also caused some damage to the shadow mask inside the screen. I mean, on the balance of probability, it's probably not likely, but I can't. Something at the back of my mind, or something in my gut, really, my gut instinct is just telling me that that could have suffered. Not that it really matters, though, because this is beyond. I'm trying to do this with one hand. Because this is beyond redemption as a restoration project. It's had it. It's just one resurrection. I'm going to give this, and then I'll be pulling it apart for spares. Another collector I know, Ian, he wants the line output transformer, which is, don't you think? Ah, there we are. I'm still getting used to camera work on this. He wants the line output transformer, and I would assume also the tripler. I'll send that to him anyway. Yeah, so this has had it. Now I have got the service manual. I've not fully studied it yet. I need to set some time to read that for my reading material. But one other thing I forgot as well about these is that this model actually was developed in partnership by Pye in partnership with Philips. I believe that the cabinet and the time-base board, power/time-base board, and the convergence board, I think, don't take this as gospel if you don't know, but I think those were designed by Pye. And then I know that at least one of these other two, maybe both of them, which I think are audio, signals, video, colour decoder. In fact, that's almost definitely a colour decoder. That looks like the Pyle crystal. It's made by ITT. Oh. Okay. But anyway, I think that at least one of these, possibly both, was designed by Philips. And there is actually out there a rare, don't know if very desirable, or maybe desirable, I don't think very valuable though, but there is a rare Philips version of this model. You can probably look it up on your favourite search engine. Now this is the first colour television that I've actually ever done a full restoration on. I have repaired other colour televisions, but mainly those are 1980s. Those were 1980s models, like the like Thorn TX9s. I think I've done Rediffusion as well, Rediffusion Mark IV. But those were just repairs of sets that had already been working in my time of owning them. That is the tube type, an A47342X. I do believe that these aren't actually manufactured by Mullard. These were I think I have read somewhere that these were made by Toshiba in Japan and were imported by Mullard themselves, not by Pye but by Mullard, and then sold on to manufacturers after they put their sticker on. Yeah, I'm wondering if that's where could that be where the original Toshiba type... Oh, in fact, it can't be, can it? Because if it had been there, then it wouldn't... Then there'd be dirt covering that more dirt covering that area. I think that's just another sticker. Yeah, it feels like it. Is this going to be difficult to remove? Oh, no, it's edging off. Right, oh, that's just an earth lead, I think, just to earth that. I will try and look through the guide of my Muta BMR90 first. I prefer that CRT tester, just to see if it has that type. If not, then I've no doubt that the B&K 467 will have it. Yep, A47 342X, there it is. and on this model, BMR 90, that would be adapter 802, which I think I have. There we are. There's no heater voltage setting on these tubes. You might think that weird, but that's because the heater voltage setting is determined by the connector that you connect up to it. Right then, there we are, there's the knob. Right, on. We have tube heaters. Yep, if you've picked up, by the way, if you picked up a tip from Shango, which I have, those cups in there that the tube heaters are sort of going into, they do not actually look too bad, but I don't think the emission was very good on these anyway. Right, now I just need to spend 2 minutes reminding myself how to do this, how to set this thing up. So, what does it say in here? Oh, I don't need to discharge it, this hasn't been powered up in decades. Let's see, I've already done that, already checked the heaters, they are lit. Right, so first of all, I just want to check for a short. It says, now, press key switch S2 until it locks into place. Right, okay. So, that one makes sense. In this way you've switched to the measuring short measuring, okay. So are there any shorts first of all? Figure 4 illustrates the scales of the meter. Is that figure 4? No, it's figure 3. Okay, right, well, none of those have moved, so there's no shorts, okay. Short between grid 1 and grid 2 lights up the indicating lamp L2, which is there. Okay, no lights up there either. Right, okay. And F1, FK to G1K. Oh, that's done on the meter, on the needles of the meter. Well, we've already tested that, no shorts. Right, so we don't need to do short repairs. Emission, life expectancy, beam current, focus characteristics. Okay, this is what we need. Well, I'm not expecting much for the focus characteristics because of that tube type. Setting of the opening point in 5 steps. Push button S4 until it locks into place. Right, so S4 is that one. Confusingly, it's the third one along here, not the fourth. Okay, cut off. Right, setting cut off. Right, so now you must choose the voltage for grid 1. This happens by means of changeover switch S10, which is that one. Okay, so minus 50 or minus 70. 2 voltage values can be switched on, minus 50 volt and minus 70 volt. Only if characteristics are to be measured should the changeover switch S10 be reset to minus 70 volt. In all of the cases it should be set to minus 50 volts. Right, So -70. Now turn adjusting on switches P3, P4 and P5. P for potentiometer, yeah. So P3, to the turn them anti-clockwise up to the respective left-hand stop. Does it mean the left-hand stop of the needle or of the knob? Probably the knob. These settings must not be changed anymore now, and not during the following measurements. Okay. Right. Well, I think I've already left those in. I've already left those in place. Right. These settings must not be changed anymore now. Now turn the adjuster P1, which is that one. Right. First anti-clockwise up to the left-hand stop. Right. So anti-clockwise to the left-hand stop. The needles of the meters M1, 2, 3 have to be at the 0 mark of scales A now. So are they at 0? Yep. Right, and then turn P1 in a clockwise direction. Okay, please do this gently and slowly, because at the same time you must watch the needles of meters M1, 2 and 3. Stop the slow turning of P1 immediately as soon as one of the 3 needles has just moved over 0. Right, I have to do this with my own eyes, then I can't do it through the camera. Now you have adjusted the correct value of grid 2 voltage. This adjustment has to be maintained during the following measurements. Okay, so don't mess with it. Right, so I know I'm pointing you at them, but I'm looking at them with my own eyes, because right, okay, there we are. That is about right. Okay, so just off the 0 mark. Okay, then with black and white picture tubes and other monochrome tubes, you need to watch only M1. Okay, so should there not be any needle movement with colour picture tubes? Right, well, there is needle movement. Right, so here I think is the most important bit now, or the most important bit for me at the moment. Right, press key button S5 until it locks into place. Right, so if that is S4 that's pressed down now, that is S5. The measuring range is herewith switched on. Oh, okay, herewith. Right, posh words. Right, so read the emission current values from scales A of the meters. Okay. Oh, okay. Okay. Right. Not as bad as I first thought. Okay, that's actually showing quite good on all 3. Quite good and balanced. Right, oh, okay. Right, and so all 3 good. So good colour picture tube systems must show current values from 0.7 milliamps to 1 milliamp on the meters 1, 2 and 3. Right, so yeah, that's good. Between, I'd say that they're about 0.7, so it's about okay, so good. Right, so that is not as bad as I first thought. Right, no shorts. Okay. Right, and then I'm not really bothered about life expectancy test. So I may also offer this for its tube then as well, because these tubes in that good condition are fairly rare. We've got the mains lead out. as part of getting that board out so I can work out where the wires go. Yep, I'll need to wire a plug on there. In fact, I may just put it into my new toy, which is a new to me, Variac. So I may just wire it in there. Right. So I need to work out where all of these wires go, and it seems as though there's more wires here that are unplugged than there are sockets to go on here. So I'm thinking that some of them may actually have been unplugged from this board. And for this I'm going to need the service manual, so that well, I mean, they all seem to have plugs. For instance, that one's got a socket for 6 pins, that one's got 4, that one's got 2, so, and that one's black. I think the colour of them at the end has some significance as well. So I might actually be okay. In fact, I think I am actually, because it just looked, a couple of minutes ago, it just looked as though there were more loose wires than there actually were, but now you can see it's just a tangled mess in there. That was giving the impression that there were more loose wires. So yeah, just those 4. I think I see 1, 2, 3, and then 4, the black one there. Right, so these should... Right, so I should just be able to plug these straight in then, without the use of that. Right, well, you just missed an entire video because I thought it was recording when it wasn't, but I've just plugged in all the boards there, all the cables. Oh, almost all. Let me just plug the tube in. And these go in a certain direction. There we are. Right, but that looks like it should slide in more than it actually does, and it looks like it's been blocked by something. Can't see what is doing it. Can't believe I'm dipping my hands in this. Oh God. No, it's not that wire. Does it actually have a stop there? Let me... Looks like it does actually. Yeah, okay, it doesn't, that is it, fully the way in. You can't quite see on the camera, but that is where the sort of plastic rail ends. Right. Okay. And what is that? Oh, that's just a clip or something. Sorry, I'm feeling like I need to sneeze from this now. One repair I've done already is this. Because previously there was a white cap on here that had a metal jack on the inside of it. That is for the focus voltage, and the focus is supposed to connect to either that pin or that pin to determine the focus voltage, and it wouldn't go into either of them no matter how much I tried to cajole it, so I've just soldered it on there. There's a turd on my bench, keep me going. There's a turd on my bench. Whatever. I'm not into religious songs really, but that's just the one that first came to mind. So that'll probably be the title of this video. Next thing I'm looking to do is to chop that out, because that's the mains filter capacitor, or mains interference filter capacitor. If we switch it on, that will go bang or go short circuit, which will take out that fuse. So might as well just take it out. That's the mains filter capacitor out. It was there. Right, we are almost ready, I think, for powering up. One discovery I have made is that it has these little green Phillips capacitors. They are usually used in TV set applications, at least. They are usually used as line output tuning capacitors. And these often start going short circuit, which causes the EHT to rise and then punches a hole in the side of the tube. I know this set is pretty much scrap, but I don't think it would be a good idea really for me to leave that in anyway, because I don't want to damage the line output transformer in case for Ian, in case the line output transformer is good. So I think it would be a responsible decision to at least find something that will replace that, because those are very odd values. See if I can, let me just sling that. I want to see if I can at least find something else that's similar or close, just as a temporary measure, while I wait to get something else that will work with that. When I get something that's the exact value. Right, I'm all fed, watered this evening. I've just had my dinner, and I have spoken to Ian, whose line output transformer this practically is, and the plan of action for that capacitor, I've already ordered a suitable replacement. That's coming on Tuesday, it's now Saturday. What we will be doing is, instead of me changing that capacitor for one that's the closest value that I can get, and the closest value that I can find is not very close, instead I will leave it in for now, but I will keep a close eye on it over the next couple of days. If it does decide to start giving grief in the next couple of days by going open circuit, which, as I said, causes the EHT to absolutely skyrocket, which could damage that, what I will do instead is I will, in that event, I will take it out and then just bridge a wire across there. What that will do is it will cause the EHT to go lower, which will give us a very dark, ballooned, blurry picture on the screen, but it will at least protect the line output transformer. So it will give us lower EHT voltage rather than sky high EHT voltage. Another thing I've spotted as well is that fuse is missing, and that has been missing for a long time, because you can see dirt in the fuse holder clips. So that's not been freshly removed at all. I'm going to have a look at what that does, fuse 691, because that's been removed for a reason, and this has all the hallmarks of a TV that was taken into a technician, an engineer, repair shop, whatever, and they just couldn't fix it. So I bet that they took that out as a part of the diagnostic process of their troubleshooting. Yeah. I've spotted it almost straight away looking at this diagram. I think that comes from the HT, or probably boost HT, but where it feeds into is not good news. It goes down here, down here, down here, down here, down here, goes through there, up there, up there, up there, up there, through that resistor, and then into there, and then into there. This column here, that there, is that, which is the part that Ian needs. Shit, I hope that that's, I'm just hoping that that's not a sign of something, but I'm beginning to think it is. Right, I have just noticed that that fuse and that fuse, they both feed into the same winding on the line output transformer. So I am hoping that either of these two capacitors or that diode may have gone short circuit. That's what I'm hoping, because if it's the line output transformer, then Ian will just have to wait for another donor. But we're getting close to switching on time. I've already taken that out. I actually can't think of anything else that needs doing apart from connecting that back. Oh yeah, I need to, what I will be doing actually is I will be measuring the current across both of those fuses, because something has definitely gotten short circuit there. In fact, what I'll do is I'll find those components and I'll test them right before I even switch on. Just testing those components. The capacitor itself was absolutely fine, or nearly, but it thinks of the diode as a capacitor. 29 picofarad capacitor, and the other way around it says no unknown or damaged part. I think we have our answer. Right, and the diode test on that meter says that that's okay, so could one of these clips be bad? Well, my peak component tester seems to recognise it as a diode, so the diode seems to be okay then. What's up with that? Okay, and the atlas says short circuit on the green and blue. Okay, that capacitor is actually faulty. Right, I've changed that capacitor. What I decided to do though is the diode still seemed to be okay. So put that back in, but that capacitor, yeah, I've changed it. Right, so we are on the next day, 22nd September. What is going to happen? First of all, I'm going to switch that on and make sure it's on the amps range. Yeah. And that is connected up to, let me just get it. It is connected to, let me just try and find it in the circuit. Where are we? Line output stage, right, and this is the page that's upside down, isn't it? Right. So that meter is connected up to that fuse because I want to measure the current going through there, and the secondary meter is connected up to that fuse because I want to measure the current that's going through there as well. Yesterday it would make the degaussing sound, which was a buzz, a bong on the first second or so, so it was... We know at least that the degaussing circuit is working, but nothing much else. Right. So here we go, stand well back just in case it decides to let go. Nothing, no current draw. Have I switched it off? See, I don't know. See, because on this telly, I can't remember if you pull the switch in or out to switch it on. I pulled it out. Let me just try it again. Well, the degauss fired, and that had a little bit of current draw, not much. Okay. No tube's lighting. Tube isn't lighting up. I think it's, from what I remember, I think it's powered from the line output stage. Ain't much going on from the sounds of it anyway. Right, okay. I've just noticed, I've just taken out that fuse there, which is below, between the two that we're having issues with. That is blown, but when I tested it yesterday, I initially didn't notice that because I just put my meter clips across it and it beeped perfectly fine. But I've just noticed that that is blown, and I put my meter across it and it still beeps. Right, so we've got a short across that T541. That is 541, which is there on the output of the power supply, and also feeds up here, which is where we've been before, up to that fuse, and then there. So I think something catastrophic has happened to that line output transformer. That's what's making sense to me. I do just want to measure whether that 536 capacitor down there is short, but oh, hang on, it measured short directly across it. What could be bridging that? Unless... I'll have to think about this. What could be causing a short directly across it? Because that's not a direct connection to earth. That isn't, because we've got the resistor there. That's not, because we've got the pot and the resistor. I'm going to have to think about this. I think it's because I was just measuring the fuse 541 with my other meter still across fuse 683, so I think that was yeah, because now that I've taken that meter out, completely disconnected it, and I put the two probes from my other meter directly across 541, we've now got no short. Okay, so that was just my idiocy. Right, I think we may get somewhere this time. That meter is still connected to fuse 683, which was the one next to the line output transformer. That one is connected to This one down here, it's connected to that one. I don't usually like using analog meters because it takes a bit of squinting to work out what number it is, whereas something like that, which is connected to the fuse at the top up there, gives you a big readout, right, that you can just glance at. Right, here we go. Oh yeah, oh yeah. Something down there is going up. Right. That was that resistor there. Has it blown the fuse on that? It just tripped it a bit. Okay. We have got a huge short here. Right, and it's a cross resistor 746. Workshop is starting to stink now. I think I saw something lighting up as well. I think that might have been the overvolt protection, the glow lamp. I just want to get what happens on camera here. Yep, that overvolt is behaving. Okay, and it flashes. Right. Okay. Yeah, that is definitely resistor 746 that is barbecued. Right, and 746 is there. It feeds into the frame stage. That capacitor 747 is our main suspect here, I would say. If that's gone short, then it will blow everything else, I think. I've just taken that capacitor out and there's still a short there. Not much to do with the TV under service, but I've just got to share this. I love it when TV engineers leave their thoughts in old TV service manuals, and then Paul Stenning uploads them to his website without editing, without censoring. Because things like this, where it says that little bastard, it's a piece of history, that. I think we have our answer. This only seems to, this one, which is the BD233, which is that one there, that only seems to measure as a 3.9 ohm resistor between the pins 2 and 3, which are for collector to emitter, and pin 1 measures nothing. I've tried this several times before starting filming this bit. Pin 1 is just complete open circuit. Complete open circuit. Whereas if we try the BD 234, Alex trying to do this one-handed. BD 234. If we test that, that measures as a transistor or double diode, which is what a transistor really is. That is that one. So that one seems not to be right. It seems to be it's not behaving right at all. And no wonder it's short. Well, no wonder there's a short there. But yeah, I know it's definitely one of these, because when I took that one out, the short here, which is there. Don't know if I shot it earlier, but the short there disappeared. So I would say that that is gone, and I do not have any BD233s in stock. I've placed an order for them, I think. Yeah, but this, I'm gonna see if I've got an equivalent that can substitute. A few days later, and I'm back at the Pye. So I forgot to explain how I narrowed this short circuit down to these two. First of all, I unsoldered one end of resistor 746, 22 ohms I think it says there, so just to cut off, just to isolate the short from being there. The theory being that if that point didn't test short afterwards, then the short isn't on that side. I know that normally a resistor wouldn't. Normally you wouldn't be able to measure a short through a resistor, but because that's only 22 ohms, I thought maybe my meter could fix that, or could pick up on that rather. I don't know, but anyway, I then and also resistors can themselves go short circuit. It's rare, but they can go short circuit. So what I then did, first of all, actually, I unsoldered that capacitor, because I suspected the capacitor first had gone short. I mean, come on, that's probably the most likely explanation. But no, that tested fine. So with that out, I then unsoldered one end of that to rule out that end there, to rule out a short on this HT line or whatever it is. No dice. I then unsoldered that resistor, just in case that or any one of these had gone short. Unsoldered one end of that. No dice. The short was still there. So that left. That meant it was either going through there or through there. In fact, no, it doesn't. If I've desoldered that, it means it's going through there, doesn't it? So that then leads us to 2 or 3 different ways. Oh yeah, just in case it was going there through the diode, then there. Desoldered one end of that diode, still a short there, from there to ground. So then what else did I do? Oh yeah, I desoldered that, and in fact I desoldered this before the diode, so that there was no short going up, because that's on a different rail going up to the frame scan coils. No dice. Then I desoldered the diode. No dice, still a short there, so then that meant it was one of these two. If I scroll down a bit, sorry, I've had a pop-up come up. If I scroll down a bit, there is also a capacitor down there. I still haven't tested that. Right, oh, in fact, no. Oh, okay, no, I'm getting things a bit confused. Right, so it just goes straight down there. So there shouldn't be a direct short going through those transistors. That one tested okay. That one gave some weird readings. And because both of the diodes are similar, because both of the transistors are similar, I didn't think that they would, that there would be that much of a difference between the two when testing them. So what did I do next? First of all, I zoomed out. I bought a whole shed load of transistors, diodes and thyristors, because this is the first fully solid state television I've ever done, that I've ever done a full restoration on. I've done basic repairs on, I think I've already mentioned earlier in the video, I've done basic repairs on 80s televisions, but it's the first time I've gone deep to actually fix one of these properly, fix a solid state TV properly. And as a consequence, I didn't really have that much in stock of transistors. Mainly my expertise is 50s and 60s sets, which use loads of valves, and I got probably a good 100 or so of those, maybe a couple of hundred. But not much in the way of transistors, so I've decided to start building stock of transistors. And basically how I'm going to do that is ordering the transistors that I need just on any set. If there are any transistors that, if I start doing a set and I don't have any of the, and if there is a type of transistor or diode or thyristor inside it that I don't have, then I'll order it just in case. I'll order, I feel like 5 or so on just in case, or whatever. Anyway, so I've ordered almost all of the diodes and transistors and things. There are a couple that are unobtainium through regular sellers on eBay, Amazon, even specialist parts websites, but some of the guys on some of the collector pages may have some spare in case I need them, so I've only ordered what's readily available. Right, and I am determined to get a picture on this tonight. I've only got, what, 3.5 hours, maybe 4.5 hours until I have to be in bed because I'm on an early shift tomorrow. So let's get cracking. Was there something else I wanted to say? Don't think there was, actually. Oh yeah, I've remembered what I wanted to say. I have not ordered a replacement doubler, just because I forgot to do so. So I am hoping, fingers crossed, that is okay. If it shorts out, it makes itself very obvious. Not necessarily because it's dangerous, because it absolutely stinks the place out of rotten eggs, or so I hear from television engineers of the day who used to service 70s sets like this. Voltage doublers or triplers. Most TVs have triplers, which are this, basically this, but just to a higher voltage to power the tube. But yeah, I've never fixed a television. I think I've fixed a couple of TVs with triplers, but not to the tripler itself. The tripler in those wasn't faulty. You might hear some noises from outside. It's because it's 5:30 on a weekday evening. Kids are coming home from school and all sorts of other stuff. So first of all I want to put in the new BU105 line output transistor. Someone on the UK Vintage Television Collectors, I think it was Ian, I think it's the same guy who I'm keeping this for, he mentioned also that one thing that can kill the BU105 diodes is if these washers go short circuit. He said mica. I've tested these. They haven't gone short circuit, but looking at these, I don't think they're mica. Oh, I suppose they could be. I guess they could be, okay. But at first glance, they look more like plastic to me. But yeah, also first thing I'm going to do though is replace that sort of pastel green. It's not pastel green. What kind of green is it? Turquoisey green capacitor. That's the one I said earlier in the video that must be replaced on any televisions from the 70s. I think even the late 60s and into the early 80s, but any television that has those capacitors, that particular colour, they must be replaced. They might work for a short while, but they will eventually go open circuit and start causing all sorts of problems which are not deathly to you, but will be deathly to a television set. So those have to go. Replace them before even switching on. As I was saying before I was so rudely interrupted by the man outside, replace those before you even switch a television on. I know that I didn't, I took a risk, but yeah, replace those before you even switch a TV on. Even if the television doesn't work and seems to be a waste of time, like this one might be, any replacements that you put in there, you can just recycle, reuse, recycle, whatever. You can just take them out and then put them back into stock for something else. But anyway, yeah, that is what a mica washer apparently looks like. Thin sheet that goes between the transistor and the surface it sits on, and there's nothing there of that kind. There's nothing, I don't even recall there being anything of that kind that I took out. And I've just had a look around. There isn't one. Okay, so that's probably how this television set's failed. The previous transistor would have failed. The engineer, probably with the mica surface, mica protector, the engineer took that out. Didn't think the mica protector was important, put a new one in. Probably without the mica protector, the TV probably lasted days or weeks before it went wrong again, because it didn't have that. So so no wonder that would have gone short circuit. I think my camera's going to find it difficult to focus on this. It's in focus at the moment, right, but thanks to the help of Chris on the UK vintage television collectors, well I suppose they are correctors, they repair things, but thanks to the help of Chris on the UK vintage television collectors things, collectors page on Facebook, whatever, you see within those holes that there's sort of like a rough edge to them, right before you actually get to the gap that makes the hole itself. Right, and my camera can't zoom in any further, that is part of the mica not heatsink, but mica layer, and it is sandwiched between this right, it is sandwiched between this and the metalwork. Yeah, I sound really well, don't I? I'm wondering if it could be this sheet here. Probably best not to pick it, but let's do it anyway. Yeah, I'm wondering if it could be part of that. But it doesn't seem to be short circuit, that mica sheet or whatever it is. because I've put the old transistor in, not powered it up, but just put it in, and then tested base, tested if there were shorts from base to metalwork, none, collector to metalwork, none, and emitter metalwork to none. No, and there weren't any. Oh, and if you're going to be working on one of these in the future, I'm not an expert, by the way, I forgot to do my disclaimer, I'm not an expert, so if you don't watch this for educational value as such, not for electronic theory or repair theory really, because I'm still a bit of just an amateur hobbyist at this. Right, I know what I know, but yeah, I won't take any liability if you decide to use this video as an educational thing and then blow yourself up or whatever. Right, your lack of self-awareness of your skills, now that I've warned you, your lack of self-awareness of your skills is your problem and not mine. But anyway, in case you need to service behind here, as I've just needed to, that, as you can see, is kind of tight. So this, I think it's a mains dropper, this comes out. It's kind of hard to do with one hand, but you can probably see there, it just slides off. Right, it's kind of tight on. It grips, but it slides off. As you can see, it's starting to now. But yeah. Right, so that is the next thing on my itinerary. I've resoldered in that capacitor. There was a transistor that lost a leg when I resoldered it, when I desoldered it, so I've had to put in a replacement. I think it was the BC337 in the frame stage. I've soldered back up the diode and the resistor behind there. Oh yeah, and that transistor down there, which is that one, needs resoldering. So I'll put that in now actually. Then I will take that out. And what I will do, and on these power transistors, really you must do this every time that you change one, but I'm going to put another one in, but I'm going to put some heatsink compound on it. The old one had some, I can still feel it sliding away when I put my fingers on, but that's 50 years old, so I don't, for some reason at that age, I just don't trust heatsink compound. It might be fine. It might be fine for all I know, but in my lack of knowledge of how heatsink compound behaves at that age, I think it's probably just best to err on the side of caution. I mean, what heatsink compound costs? Only about a couple of quid, what if that, and you get a few squirts out of it. So, but yeah, that in order. That heatsink compound, and then transistor. Then what I will do, just in case it starts blowing up, just in case there's something else that starts blowing up, is, and some guys are probably going to be calling me really stupid for this, really, which is why I told you a few minutes ago not to trust me for repair, knowledge, but I will actually bridge these with crocodile clips just to see if there are any more shorts, because I don't want to just keep on just blowing fuses willy-nilly. In fact, what I will do after I've changed those three things, instead of bridging those fuse gaps, what I will do instead, before I even switch it on, is I will test each one of these 8 solder pads which connect to the fuse clips on the other side, I will test if there are any shorts between those and chassis, those and what is effectively earth ground. That's what chassis is. Just so I can try and clear any further shorts before I switch on. I almost forgot, those two transistors will need to go back in as well. Don't think I've got enough heatsink compound for both of those. I think that green capacitor has been replaced before. That soldering there does not look original. Compare it, compare, where's my finger? Compare that with that. Compare those two. And so you can even see burn marks on the board. That's been replaced before. Yeah, and there, look, see, and there's been some work down there, and also up there. So this set has had a history. There's been some work done there. There's also some work down there, but that might even be my work. Have I replaced anything there? No, I have not. Okay, that resistor's had some work on it. Looks like a high wattage resistor. That resistor looks original, but the soldering doesn't, so it's possible, where are we? So it's possible that that's just been, that the heat from that resistor caused this to go dry jointed, heated up the original solder so it went dry jointed, and then someone's just touched that up. And there it is, the capacitor that causes so much trouble on the 70s sets. And this particular one is 2.7 nanofarads, and I ordered some of those. This one's rated at 1500 volts maximum. The ones I've got are rated at 2000 volts, I think, if I remember rightly. So my replacements will be more than enough to deal with the job of line frequency tuning. It still tests as a capacitor. (2,879 picofarads), so let's call that 2.8 nanofarads. Right, so that's close enough. 2N7 is 2.7 nanofarads. I can't this decide between whether it's pins 1 and 2 or whatever. What's wrong with this? See, 2, 3, 1 and 3, 1 and 3 again, 1 and 3 again. Oh, it's settled down now, but yeah, that were, oh, and doing again 2 and 3. What's janky about this? I think the battery may be on its way out, but yeah. So that measures on spec, but I don't trust it at this age. These are not to be trusted. If you see if there's one of these inside your television when you're examining it, this is one educational piece I'll give people. When you're examining a television an old vintage television, these were used in sets from the late 60s, dating from the late 60s to the early 80s, and if you do a visual you should really do a visual inspection before even switching on, like I did. Don't take your chances, just replace these. even if the set proves to be junk, just replace them. If you replace it with a new one and then the set turns out to be junk afterwards, chuck this away anyway, and then reclaim your replacement, and then keep that for stock in case you need it later. I think I've been a little bit liberal with the transistor cooling paste, but that is the original. That one tested fine. I've put that back in. That one is new. Probably doesn't look like it. As I said, I've been a little bit thingy with the paste. There we are. Don't know why I'm not wearing my nitrile gloves. Anyway, I'm nearly done for tonight. Anyway, just put that back and just bent that out of the way just to make it a bit easier to access. Still need to change that and put a new capacitor in there. Just changed that green capacitor for one of these, and the order sheet says just make sure that my address is hidden. Right, the order sheet says that 2.7 nanofarads 2000 volt ceramic. I've just asked someone. I've just asked Chris. I've just asked Chris if ceramic would be able to deal with the high voltage pulses that are there in that part of the circuit. One thing I've discovered as well, I think they covered these solder points earlier. These are for, I think that is a resistor below that. Another high wattage resistor that's got hot. Let me just get my lamp down there. Quite hard to see with that as well. But there is a high wattage resistor underneath that. There we are. That looks like that's got pretty toasty under there. So what is that yellow thing? Is that capacitor? But yeah, it looks as though that's been touched up, so that, like the other one, that one's got hot. I think you can even see a bit of it peeling off. But that's got hot. And it's got so hot that it's caused dry joints there. So someone's touched up the soldering there as well. I've just been speaking with Chris. That kind of capacitor, because the dielectric is ceramic, is not to be used, really not for long periods, in applications where there's tuning involved. And I understand the reasoning now. It's because ceramic dielectric is not very precise with the capacitance. So it's 2.7 nanofarads, but it can vary a bit. And in tuning, any kind of tuning, you need precise capacitance. So I'll just use that as a temporary measure, just to test if there's anything else wrong before I get some ones that will work in that application, before they arrive, which I've just ordered. It's a good thing I decided to test these fuse things. I've not put the line output transistor back in yet. It's a good thing I decided to test these. Look. Fine, fine. Testing for shorts. Fine, 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 fine. Big short. Or rather, well, doesn't say 0 on there, but so there is still something seems to be shorting, and it goes to a transistor over here, unless it's just the way that the transistor is configured, unless it's, yeah. Let's have a look at the circuit diagram. Right, my brain's way too tired. That transistor is that one there, that sort of a wedge-shaped one. Those are Mullard lock fits, and they are universally trouble. What's this supposed to be? So I can't tell whether it's 704. I can't see where it says 704. I can't tell if that relates to the capacitor or the transistor, or whether the 702 relates to the transistor or that resistor. So let's have a look in the diagram. There it is. There's no way that that's supposed to have a short to ground. No way. Let's do a capacitor and a resisting capacitor there, and then that goes through a resistor, and that goes through the resistor. So yeah, there's no way that that's supposed to have a short to ground. No way. I just went down a wild goose chase there. It's not that one that's short, it's that one, by the looks of things. It's not even that transistor. It's that junction there between these three resistors. So why would that measure short, that junction? I'll need to have a look at what these resistors are. 709, 723 I think, and 725. Those three resistors, there's one, 709, 725, and 723 is down here. I've just scrolled up a little bit. There, 723. That transistor might be okay. I'm 50, I'll test it. I just want to test resistor 725 at the same time. So that entire HT rail is being short-circuited down to ground. This is the same rail that those resistors link to, and also to that 315 milliamp fuse where I tested one side of the fuse holder, or tested both sides, and one side was short. That frame shift there, frame shift pot, I'd say is our main suspect, because that is the only component there that connects. That's just one single component that connects it to ground, and that is this guy. That is this guy here, with the back off it. That looks, if I just that looks in pretty bad shape. That looks really bad. I think we're back to square one. I think I've just been led up a complete blind alley by this thing. Which I can only partly, well, really blame on my own ignorance, because remember, this is the first time I've ever serviced a transistor set. Is this kind of thing normal? I mean, it measures, it beeps, but it measures 022 or 023. Maybe that. Let me measure the resistance. I have been led up a blind alley. Right, so I think all this is down to that being short, and I now think I'm beginning to understand. When I started with all this, some of those fuses were not blown. Some were, but some weren't. And when I overrode those fuses by connecting up my meters, I don't know the other ones. When I overrode those by connecting up my meters to bridge across the failed fuses, that must have caused more current or something to flow. It must have caused more current to flow through the remaining resistors like that. The remaining fuses like that one. I think I was a bit of an idiot in wanting to measure the current if that was short circuit. Learning curve. Let's put it down to that. Right, it is now 11 o'clock. I have to be up in the morning about 6 o'clock, 6:30 for my early shift. The only thing I've left to do, which I won't do tonight, but the only thing I've left to do before I switch this on is put the fuses in. I'll do that tomorrow afternoon, which is when battle commences to get this to work properly. Right, it's the following night, a bit later than I wanted it to be. I think we are ready to switch on. I've put the 4 fuses back in. I don't see anything else that needs attending to. Let me just, those are nudged over a bit. Let me just put those back where they should be so they don't short against anything, even though it didn't look like they were shorting before, but whatever. Any other TV repairman, either retired, still continuing, hobbyist, whatever, do any of you have, with solid state stuff, do any of you get a sense of trepidation after doing a lot of work to fix an issue and then get a little bit, and then get butterflies in the stomach, just in case it blows things again? One thing I do just want to check is whether, I just want to double check whether I put that capacitor in right, that was the right way around, because now when I think about it, I'm kind of convinced that I didn't. I just want to check that, because that was one of the first things I did on this telly. Right, I'm standing back, just in case this cheap pile of Pye shite decides to expire. Right, here we go. I want to focus on that area, keeping the camera near at arm's length, camera near the TV but away from me at arm's length, just so I can record and zoom in and view live what happens here, just in case. Nothing. Okay. Right, well the switch on the front is pulled out, so let's watch. Nothing. Push the switch in. Switch on again. Nothing. That fuse is okay. I've just tested it. As is that one. And when I switch it on, I don't hear the because it's a colour set. I don't hear the degauss. Where is it? This degauss coil around the tube. I don't hear that firing. Just going to rule out my lamp limiter by plugging it directly into the isolation transformer. See if we get anything from that. I'm going to have to be careful with that because there's no switch on there. I can only switch it from the knob on the front. Never ever test a plug like this with it plugged in without you knowing what you're doing. I don't know that much about televisions, but I do know enough electrical safety to never ever do this without having some form of safety. But there's no... I've just put my meter on testing AC voltage, and there's no voltage there across the line, across the live or the neutral. There's nothing. That neutral looks like it's slipping out actually a little bit. Let me just tidy that up. Right, I think I fixed the lack of power. The 3 amp fuse in there had blown open. Right, I think this could be it. Right, switch on. Still nothing. I push the switch in on the front, switch on. Again, nothing. Guess what? One of the fuses inside this was also open circuit. I'm going to have to fix that switch at some point. I reckon it's that that's done it. Right, I have tested the mains switch, the back of which you can see there. Yep, that's green and oxidised, but you can see that there. Out is the, when it's pulled out of the when the switch is pulled out is the on position. Right, shall we give this another go? Still nothing. I'd missed that, but when I switched it on, that 315 milliamp fuse had blown. Right, so we have EHT then. You can hear it there. Do we have tube heaters? We do. Right. That 315 milliamp looked like it had blown. I do not understand. I've just changed that fuse. Watch what happens. See? Does that as soon as the speaker starts. In theory then, I'm just going to test this very briefly, but we should get something on there. Probably not. Okay. Oh, we had something there. Okay. Just come back after a few days. The new proper capacitors for the line output tuning have arrived. At least I think that's what they are. Just chasing a frame fault. Now, I explained to Chris my theory out of pure ignorance that I thought that the loose tuning, the loose tolerance on that, because it's a ceramic capacitor, the loose tolerance on that might be causing this to start up a little bit slower and be a bit more coarse in its tuning when it's line output tuning when it's starting up. That then may be blowing that 315 milliamp fuse there. But now he said that only if the HT was excessively high, and it didn't look excessive. I know that that was crackling, but it didn't look excessive because the width wasn't coming in. The width reached right across the screen. So I am looking for frame output issues. Now, what I want to see is see if we can get any sort of height from it, because then if it's, or frame stage issues, I'm looking for frame stage issues. What I want to see is if we can get any sort of height from it, or what I originally wanted to see was if we could get any sort of height from it, just to see if there is any, if the height can be adjusted. If the height can be adjusted and if it has an effect on the screen, then it's a frame oscillator issue. If we don't have any height that can be adjusted normally on a set, we would have a frame output issue. Right, unfortunately, I've just booted my computer up, so that's why I'm seeing loads of spam and other crap from Windows. Oh, go away, Avast. Go on. Unfortunately, the height and the hold are back here rather than what I'm used to on a valve TV, which is where the height is here and the hold is over there. I don't even know if that's typical for a transistor set, but whatever, they've done it on this set, so we can't use that theory, I don't think. We can't use that diagnostic test because the height and the hold both seem to be around the frame oscillator, not hold on the oscillator, height on the output, as is usual for most of the televisions I've done thus far. Now, one thing, because this is a delta gun set, set with a delta gun tube, as any colour set from the, apart from Sony, any colour set from the late 60s and early 70s will be, it has to pass through the line, and the line output and the frame output both have to pass through the convergence stage. Sorry. Yes, I know I'm being tracked. Okay, they call it Facebook. Right, anyway, the line and the frame output stage both feed into the convergence stage, which converges the three images produced by each of the three guns in the tube: the red and black image, blue and black image, and green and black image, which all together, if they're perfectly overlaid on each other, produce a colour picture. Convergence controls how they overlay. And on here there is, I can't remember, on a delta gun set there are two convergence stages, and I can't remember which one is which. One of them is done around the magnets. I'll have to look it up in a bit when it might be relevant, but one of them is done on these magnets. You'll see there's a third one under there, there and there, which I believe controls the convergence at the centre of the picture, because the electron beam is not travelling in a straight line. It's travelling, or the electron beams rather, in a colour set, they're travelling from a straight line here, and then they get to here, and then they're being diverted all around in all sorts of different directions. So yeah, and the screen itself is not perfectly straight, it's curved, so you have to have some, that convergence will only work in the convergence towards the centre of the screen, towards aligning the picture in the centre of the screen. So you have to have an extra convergence stage called dynamic convergence, and I believe that that is what this is called. As it, again, I may have got the two names mixed up, but this board on a delta gun set controls the convergence around the edges of the screen. Now remember when I said that both the line and the frame stage have to go through the convergence stage before they get to the scan coils, which is what actually deflects the beam in all directions, the electron beams in all directions. I think we may also have a problem here. Look at that. You know when Shango says baked, 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 what's the opposite of baked? Drowned, maybe? Drowned. Completely Lancia beated. Look at them. Look at that. Totally Austin Leg Road. But the only thing that's making me doubtful whether it is that whole stage, it may well be one or two pots on there, or a connector on there, or something, I don't know. The line stage is still working, and that has to pass through here before it gets past to the scan coils. So I am wanting to look, first of all I want to look if there is anything in the frame stage, again, that could be causing a short circuit and causing that fuse to blow. Also, I want to see how, if there is any direct connection between that fuse and the convergence stage. From memory, from looking at the diagram a few days ago, I believe that there is, but my memory is probably more, or probably less reliable than this entire television set was when it was new. So I think I want to have a look. In fact, I've just realised this diagram doesn't seem to quote any voltages, at least on here. Maybe they're on another page or something. Doesn't seem to quote any voltages on there though. But anyway, so yeah, I want to see if we can get. I want to see, whether all the whether there's any shorts first of all in the frame output stage. I know I did that in the past, but I only checked certain components. I want to check other components that I've not checked so far. If they're good, then I'll go over rechecking the components that tested fine earlier, because they may well now have given up, now that they've had a current pass through them, or voltage or whatever, now that they've had power pass through them. But I also want to check on the frame oscillator stage, because I've not had a look at the oscillator yet, and also I want to have a look there. And also Ian suggested looking at the connections as well, the connectors, because apparently the connectors were none too reliable. And looking at what some of them look like, because it's, when you get them out, it's quite hard to get them back in fully and make sure that the pins are making contact with the sockets. I can well believe that. Right, so let's get cracking. It was the proper capacitors that arrived this morning. Right, I have just put that capacitor in. So now, as I said, I want to test the frame stage that's fed by that fuse. Oh, by the way, that fuse does sort of feed into directly into that stage, because look, there's that fuse. It feeds down there, there, through the frame shift pot, and then through that resistor, then up into the convergence stage. Then through into the convergence panel, and then it goes through that, and then it goes into the scan coils down here. So just zoom out. I also just want to test that diode as well. Now, unfortunately, if that has gone, I don't have any replacements for those. So if that's gone, then there's going to be another gap between before I can record the next bit. Well, that one, which is the 220 there, that one seems to test fine, except on, it tests fine on there, there, and there, except that one, which seems to register a short after a few minutes. So it could be suspect. So what I may well do is go back and test, which was it? There was another one I took out earlier and then put back because it tested fine earlier. Might have been that one, I can't remember. But I'm going to test that one, that 737, that tiny one there. And also, what does that 732 do? What do those two do? I'm going to have a look at what those two do as well. I'm going to test that tiny one. In fact, I'm going to test all the electrolytics around there actually. Right, I've just been through and tested all of those capacitors. Nothing wrong with them. I've made both a bit of a discovery and also a bit of a boo-boo. Right, the boo-boo first is that down here I put in a 22 microfarad electrolytic rather than a 220, which I've now just replaced. So 220 microfarad, because that was 150. I don't think anyone makes 150 anymore, so 220 is the nearest one up. One other discovery that I've made is, let me just get back onto it. What I've done is I've ordered the more service information, because all the service information seems to be split across several documents. That I've discovered that, well, that is the 315 milliamp fuse there. That's the one that keeps on blowing. It doesn't just feed the frame stage, it also feeds the sound stage. It's part of a 40 volt supply rail to those two. So what I've done is, this was plugged in, the sound stage is on here. This was plugged in, so I've pulled it out to disconnect the sound stage. Now that fuse blowing, which I've just replaced, that could be down to either, I suppose it's remotely possible it could be down to that having had the wrong value, but because of the circuit that it's in, it is, let me just bring it back up. That's the upside down one, isn't it? Let me just get on there. It is one of the ones there. It's that one there, 682. And I suppose it could be down to that because it's sort of linked like the. But I think, though, on the balance of probability, if it is a fault, it's likely to be down to something on here that I've not discovered, or something on there. So we're just going to see if now that has been disconnected, we're just going to see if this still blows. Does it suck or does it blow? No. It blows. Okay. The short is still somewhere on here then. Okay, I've been a complete idiot. No doubt some of you will have noticed earlier when I was fitting this, but I forgot to fit the mica washer behind, didn't I? It didn't even come with any washers. See, in my ignorance, because I'm completely new at transistor technology, the original, which, as you can see, that doesn't want to peel off, that came with a washer, but as far as I know, as far as I can tell, there's no transistor paste. I thought that transistor paste was an alternative rather than. Right, so that's gone for a Burton. So another week of waiting because I don't have any transistor washers. Here we are, probably around about a week later or something. What I've been doing for the past hour or two is I have changed. Initially, what I just did was I just took that that link thing that holds it into place. I've forgotten what you call it, but I took that off. Then, as you can see, I've put a mica washer behind there. And then I'll put a mica sheet or whatever that's supposed to be behind there, and switched on, and it still blew the fuse. So I took the original, well, not the original, but I took out the transistor that was in there, and also replaced that one, which was the original. That's the one with the rusty legs that you can see there. I've changed both of those. Changed both of those. I also just had to touch up a little bit of the soldering on here because I've moved this about so much while getting access to both of these. After I'd taken this out, of course. One end of one of the legs had snapped off, so I've just resoldered that. Put a new fuse in. That's the one that blew earlier, I believe. Is it? In fact, no, it isn't. No, I did change it, right, because what I also did while I had both of these out, both of these transistors out, is I switched on. It was before this had snapped. Switched on, and that fuse then did not blow. Right, so basically, let me start again. I had put the micro washer in there, switched on, it blew the fuse, switched off, changed the fuse, took both of these transistors out, tested them while they were still out, switched it on. The replacement fuse did not blow. So it's got to be something to do with one of these two. So I've changed the replacement that I put in for that one. So this is now the second replacement but third transistor that's in there, and then that's the first replacement second transistor that's there. BD233, BD234. Then while I think between me putting that one in and then that one in, that's what I noticed that this one, that the leg on this had snapped. So I just resoldered that. Right, if this thing blows that fuse one more time, I may just call it a day on this, because I've got all I need from this set. All I need to know, which is that the line output transformer works and that the tube works. Okay, focus on that, see if it blows. No, doesn't seem to have done so. Maybe the television was listening. Or more likely, I've finally managed to work out what's going on. Honestly, experienced television engineers, no, it's still not blown. Experienced television engineers must be either screaming at the screen, telling me, it's this, it's that, or probably, no, and that is still together, okay. Yeah, or they're probably just laughing, right, but, and I don't blame them, right. Been doing 1950s televisions for about 20 years. Sorry, no, let me start again. Alright, I've got the maths mixed up. There's about 20 years difference between this TV and those TVs that I've done previously. I've been doing 1950s televisions, right, for about just over 10 years, about 10 or 11, 12 years now. And they are, the technology inside them, and therefore the troubleshooting approach that you have to take to them, is a very, very different kettle of fish to something like this. Very different kettle of fish. So, right, so let me put that back in. Let me just check that the fuse didn't blow while... That thing must be getting quite toasty. Is that a mains dropper resistor? Probably. But yeah, that thing... Let me just check that that thing didn't blow without a flash. I'll then put this circuit board back into the set, spin it round, and then let's see what we get. Oh, and oh, ooh, seem to have got something more than a line on there. Okay, looking at just what that's giving us. But yeah, so off. Yeah, no, I need to replace that. That is actually the next job on my list, or second to next job on my list after tidying this place, because even pigs would refuse to live in this, right, or even work on televisions in it. Right, if pigs can work on televisions, do you think that pigs can work on televisions? Answer in the comments below, right, if you're even watching this far. Right, here we go. No, it's not blowing the fuse. Okay. Right, just to turn it round, I have cleared all the crap off the top of here. I have decided against plugging that in. That is the feed to the audio stage. Because remember, earlier in this, well, last week for me, but earlier in this video for you, we found that the frame stage and the audio stage were both fed from the same fuse, the one that kept blowing, but now we've managed to solve. And at one point I didn't know if it was down to something on the audio board or down to something on here before I discovered I'd made a cock up. Yeah, the dog agrees with me. Before I'd discovered I made a cock up and forgot to put the marker insulator behind the one of the frame output transformers. So the reason why I've got this unplugged still is just in case there is a problem on here. I want to be able to prove to you and to myself as well that there is now no longer an issue on here, even if it's not that there's no longer a fuse blowing issue on here, because then what that will then allow me to do is check that this is working, that the frame stage, which is this part of the board, of this board right behind this metal shield, to prove that that is working, and then if I plug this back in and then it starts blowing fuses again, we'll know that the fault is on there. Right, I mean, I know it is probably kind of remote that there would be a fault on there that would blow a fuse. Some of the service documentation mentions that it is possible though, so yeah, but chances are there's probably not a fault on there that would blow a fuse. There's more likely going to be a fault on there, but I don't think it's one that's going to be a fuse blower extraordinaire like this one was. And if you remember at the start of the call, that as well. Right, so let me slide both of those back in, take that out of the way, right, because we do not want that shorting anything. In fact, no, this set didn't even have any screws on it, did it? The back was already loose. Right. One good thing about these is that compared to other 70 sets which I have in my collection but have not worked on yet, these are actually fairly light. Probably down to their small, fairly small picture size. You know, people people nowadays may well scoff at it anyway, right, because it's not not the latest 65-inch all singing, all dancing television from Curry's or Argos or John Lewis or wherever, or Richard Sounds. But that was just me just acting as basically an advert for the entire UK electronics retailer industry. But anyway, but because it's, people may scoff at it anyway, you know, because it's not like the latest television. But even in 1972, one of the, I know I said 74 earlier, one of the service manuals mentions, was printed in December 1972, I think. So that would have been around about the time that this was released. Again, the dog agrees. And what else was what I was going to say? But yeah, I can't remember. But yeah, so I'm a couple of years out. So what I'll probably do is just label this as in the description as a 1973 set, right? Because one source I had said that this was released in 74. The other, the service manual, said 72. So let's average that out to the year between them both, which is 1973-ish. Right. Yeah, I really need to get that sorted. Right. 3, 2, 1. See what this gives us. Well, okay. I can take that, you know, it's wider than it was. Okay. The purity is all over the place, right? That's why it's white at one side and yellow at the other. Right, unless the shadow mask was actually damaged or deformed by the shadow mask immediately behind the glass layer of this tube, unless that was deformed by the same source of heat that caused that. Okay, yeah, we're getting there. Right, the picture, we are slowly opening that picture up. Remember, it was just two very thin lines now, and now it's looks a lot. It is fairly bright on the seeing it by eye. But the camera exaggerates its brightness, right? Because remember, the camera has got an electronic sensor, not an optical sensor like people have. Organic optical sensor. This has got an electronic one, so it will see things. It will see things differently. Frames vertical hold is way off, right? Even I can see, even without looking in the camera, even I can see it blinking and flashing, so that's way off. Okay, right, we are getting there. We're getting there. My first colour TV restoration. Oh, well, not a restoration, resurrection. There's no way I'm going to be able to restore that. Right, but whatever. This is interesting. Right, that is almost all yellow now. The yellow was up at that side earlier, just 2 minutes ago. Now that side is yellow, and that side is mostly, well, the top is yellow. It doesn't look like it in the camera, but the top is yellow, but this bit is white. Okay, so that's shifted. How weird. How really weird. Right, well, it's been on for a good 45 minutes or so, maybe an hour. I've not left it alone. I've been here arguing with people on Facebook just while I've been doing that, but while I've been waiting, counting time down. So, and it's not really changed. There's nothing else that's happened to it, no bangs, flashes, nothing. So obviously we're not finished, right? But I think that as far as all the really important bits are, apart from the frame output, that's fairly easily rectified, but apart from the sorry, what I was going to say is, apart from the frame output stage, we're pretty much there as far as power and time bases go. It's now just the signal stages that we need to do. So, sound, IF stages, sound, vision, tuner, and colour. Don't think I've forgotten anything else. Right, so, oh yeah, and convergence. We might need to have a look at the convergence pots, because remember, those convergence pots were in a state. Let me just see if it does this 3 coloured dots thing in the centre now when I switch it off. Will it do that? No. Okay. Usually, sometimes you get 3 coloured dots. I can't remember which order they are, but they're red, green and blue. Right, very tiny dots there. And not there. Okay. Right, so just I'm on this page, right, given that there don't seem to be that many voltage quotes on the circuit schematic itself. So check voltage at B2, approximately 40 volts. And I've also checked that it is set to pin A. Right, so do we get about 40 volts there? No, we get diddly squat. Nothing. And it also says disconnect socket B. Check voltage at contact point 2 of socket B. Socket B feeds the IF panel. Well, we've already unplugged that, so it's not on. So the fault is still not on there. It is still on here. Right. So we've got another fault on there. Right, well, I've just tested it, and it's because I couldn't do it with. Couldn't show you because I couldn't do it with 2 hands, but I couldn't do it with 1 hand, I mean. But testing it there, which is at the source of pretty much the source of the 40 volt rail, and it measured 38 on there, which is close enough. So what's dragging it down so that it doesn't, so that it measures about 0 there? I need to work this out. I think there'd be nothing at pin B2, which is somewhere down there. I think it's there. I think the voltage being absent, or there being absent, I think is just, might have just been a poor connection to it on there, because I've tested that resistor, which is that one there, on this side, and we're getting 38 volts there, which is close enough to 40. Right, so the voltage here is fine. So the voltage here is not low, and I accidentally tested it on this side of the resistor as well before realising my mistake, but it is 18 on there. Yeah, right. So where do we need to go? I think we need to That height control and the frame hold, both of them are not working in conjunction. Or both, sorry, not the control, but the height. There's not much height, there's a little bit but not much, and also the frame hold is out of whack. I very much doubt that two resistors would have gone at the same point. So I'm thinking we need to check that backwards, and I think also one of these capacitors down here, even though it's not marked as an electrolytic, see it's got two black lines instead of a white and a black, that is actually an electrolytic. So printing error there. Yeah, so oh yeah, and also that capacitor, when I took them all out earlier, all the electrolytic capacitors tested fine, but that one tested a little bit weird. So I'm going to bring that one out now actually and change that. Yeah, 220 microfarad capacitor, that's, start again. 220 microfarad capacitor, that's gone up a bit, it's gone up to 263, or it did just a second ago, it's now 257. ESR is still quite good, but that's drifted in value, so that might need to come out. New capacitor inserted. I've not bothered cutting the legs because as soon as I've got this thing displaying a proper TV picture, all the replacement parts are coming out. This is just a resurrection, not a restoration. So right, do we have any difference on the picture? Wait a minute or so for the tube to warm up. Switch my light off. Probably no difference. No, okay. Something solid state then that we need to have a look at. Something that's a transistor or resistor, and I'll be doing that tomorrow because I've only got 3 minutes of recording time on this camera, and it's nearly my bedtime. So go to bed early, get up early. That's what I like. So yeah, we'll give this. We'll test all those. Test the diodes and the other transistors in the frame stage tomorrow. One more thing I nearly forgot to explain. The reason why I've not checked either of the height or vertical hold parts at the moment is because they are both kind of set midway along the travel. Right, so because the knobs, they're kind of like set midway, so they're not at either extreme. So I don't think it's just maladjusted pots. It may well be, in fact that's another thing I'll test tomorrow, it may well be flaky pots, potentiometers, knobs, controls, whatever you want to call them. But I don't think that they're maladjusted, which is why I've not adjusted them.